6.2, so here's all the formulas whenever you take the sum or the difference of random variables. And we looked at an example last time where we had random variables which were like the number of units you took at a college, and then a new random variable might be the total cost that it is to go to the college based on the number of units. You might add the number of units from two different colleges. So there's, and we're going to do a couple of extra examples in a second where we use the sum and difference of random variables. So you definitely want to be able to find the new values without going through the whole calculation again from scratch. So what happens with the mean is also known as expected value, so I'll use E. So the expected value, if you take two random variables, we just use capital letters. If you take the sum or the difference of two random variables, x and y, or x minus y, then you would simply add the expected values or means of each individual random variable, and it would be plus or minus. So this is the most concise way to write it, and that's pretty intuitive. And you don't get these formulas on the formula card, but if you understand them, they should be pretty straightforward. And then for variance of so here's the interesting thing. With variance, if you add or subtract two random variables, the result, whether you're adding or subtracting, if the events are independent. So before I even write this formula, I need to put this right here. If events independent. You saw in the warm-up that the events were not independent and the variances did not add. Independent. If the events are independent, then the variance would be, you always add. Okay, so it would be the variance of x plus the variance, so it's written sigma squared of y. So I'm going to put like in green or something, I don't know. So here, always add, always, and that is not even legible, always add here, right here. And we're going to do an activity on that in a second. We're going to show that mathematically in a warm-up in just a second, but let's just talk about in general why that might be. So let me try to give you this example. So let's say, so the question is, why, even if you subtract two random variables, why is it that the variation or variance or uncertainty would increase? Could anyone think of maybe a reason that subtracting, like it's pretty intuitive that you adding the two random variables so that you would add the variances, but why when you subtract two random variables might you still add? Why do you still add? So think about, let me try to explain this. Think about one random variable. Let's call it C, okay? And C is the amount of cereal in a cereal box. And let's say it's about 16. But there's some variation, right? Because when you see a cereal box and you see the weight, it's not exactly 16 ounces. It depends, plus or minus some flakes, right? So let's say that's C. And then let's define another random variable, B, which is the amount of cereal in a bowl. And I'm going to take the cereal and pour some of it into the bowl, like let's say 3 ounces into the bowl. And there's still some variation there as well. So a new random variable, D, is the difference. So that would be C minus B, right? D equals C minus B. So do you see that D is not any more certain than I was when I started? There's still variability, right, in the difference. So in fact, there's even more. So just because you subtract two random variables does not mean that you subtract the variance. Okay, so always add. So that's that one. And then standard deviation. So here's the formula for that. Sigma x plus or minus y. The thing to remember here is you can't just add the standard deviations directly of x and y, or subtract. You wouldn't subtract anyway. You have to go through the variance. So what you would do is you would take the variance of x you would add the variance of y, and then you would take the square root of the sum, okay? So when you're, just be careful when you're trying to find standard deviation that you go back to the variances. So if you're given the standard deviation, you have to square it first, then add them together, and then take the square root. And the reason it's related to this, you know this, right? Yes. Okay, so you wouldn't just, to find C, you would not just take A plus B, right? You would square A and square B and then take the square root. So don't make that mistake. So don't do that. Because you know that C is the square root of A squared plus B squared. So it's, the proof is complicated in it, but it's related to that.